Hi everyone, welcome back. Today we're doing top k frequent elements in C++. For this question, we're given an integer array nums and an integer k, and we have to return the k most frequent elements. And we may return the answer in any order if there is a tie. So let's say we're given nums as this array over here. So let's copy this and add it into comments over here. So in this case, if we are to keep track of each of these counts, since 1 appears 3 times, 2 appear 2 times, and 3 appears 1 time, in this case, the top 2 most frequent elements would be 1 and 2. So in this case, we'll return 1 and 2 like this. So for this question, we have 1 to 10 to the power of 5 elements, and every single element ranges from negative 10 to the power of 4 to 10 to the power of 4. And k is in the range 1 to the number of unique elements in the array. So for example, in the previous test case, we have 3 unique elements. So k would be up to 3. And it's guaranteed that the answer is unique. So what this means is there is no tiebreaker situation where, let's say, there's 2 occurrences of 3 and we are forced to pick between 2 and 3. So this does not happen. So one approach, a naive approach, would be to keep track of the counts of every single element in nums inside a hash map. And what we can do is afterwards we iterate through all key value pairs inside this hash map, add it into a vector, so it will look something like this. Let's say 1 3 2 2 and 3 1. I guess it's more accurate to just store them as a tuple or a list of size 2, but let me use this to represent them. So in this case, the first element would be the number itself, and the second element would be the number of counts. For easier sorting, it's better to swap the positions so that we can just use the standard sort to sort them. But if you like to keep it in this way, it's possible, but you will have to specify a custom sort approach. So now that we have this, we can sort it, and after we sort it in a descending order, then we will extract out just the elements and pick the first 2 over here to return as the answer. So this would have a n log n time complexity, where n is the length of your nums. But in this case, we have a follow-up where the time complexity must be better than n log n, where n is the array size. So this hint here is hinting to us that our naive approach is not enough. So one slight optimization to that would be to use an ordered map. So an ordered map, like its name suggests, is where it keeps track of the orderings inside the keys and values. So in this case, we would have to use the keys as a way to because it's guaranteed that the answer is unique. So what this means is that for the top k frequent elements, we would for the top k frequent elements, I'm guessing they might not have duplicates, do they? Yeah, I guess that might work. So one naive approach we can do is to use a hash map to keep track of the order anyway, but instead of sorting it right after, we create another hash map. And in this case, this hash map would have the count to a vector of integers. So these vectors with integers would contain the numbers that happen to have the same occurrence over here. So let's say if we are to invert this, then what this means is we would have 3. And in this case, since 1 occurs 3 times, we'll get something like this, followed by 2 and 1. And for this first hash map over here, this is unordered. But for this hash map, this would be, for this map over here, which is an ordered map, it will be ordered. There's one problem with this approach though. Inserting to a map in C++ is log n time, if I'm not mistaken. So let's take a look at the map implementation, C++ map implementation. And if I'm mistaken, the C++ map implementation is implemented as a red-black tree. So what this means is insertion is going to be log n, and if we iterate through the collection, if we have to insert everything into this map, it's already going to be n log n, right? So that's not ideal. Or we can use a priority queue. Yes, a priority queue will work. So in this case, if we have a priority queue, which is of size k, and we will use the priority queue or the yes, it might work. So let's say we use a priority queue that keeps track of or let's call this minimum heap. So this minimum heap would have a maximum size of k. And what we will do is for every single item in this unordered map, we will add it into, we will check if these items, if this minimum heap is less than k, we would add the number, we'll add 1 here into this minimum heap over here. So in this case, let's say we see 1, we see that the current size of k is 2 and the current size is 0, so we will just add 1 into it. Next we will see 2, and because we have 1 element in the minimum heap, we can add 2 into it. And at this point, this minimum heap would have 1 as the topmost element inside this minimum heap. So now we see 3, and now we compare the counts between 1 and 3. Is 3's count more than 1? In this case, it's not, so 1 would stay and 3 will not be added into the minimum heap. In summary, this minimum heap represents characters with top k most frequent elements. And in this case, the time complexity, adding an element into the minimum heap is k log k, where k is the size of the minimum heap. So it's pretty efficient. So it's going to be more efficient than the array size. And since it's guaranteed that the answer is unique, we will definitely have duplicates in num, so this would be more efficient. So this time complexity will be O log n, sorry, On to populate the unordered map. And we will also spend k log k to set up the minimum heap. So that's pretty efficient. That would be a good approach. Is there any other approaches that we can use? We could use an ordered map. So a map to store these counts, and we can do an in-order traversal of that map to do it. But that would take n log n time as well. So that's not great. Okay, I guess that's a pretty decent approach. We will just use this priority queue approach to solve this question. So let's get started. The first step would be to import this unordered map. And the second step is to see whether if C++ has a priority queue implementation. Is there a standard library for priority queues for minimum heap in C++? So it seems that they do have a priority queue. So we can use the priority queue to store that instead. So priority queue implements a max heap. Okay, it looks great. So it seems that this priority queue would take in a key type, the value type, okay, let's see, integer, vector of integer. So the methods that we have to pay attention to for priority queue is push, to insert an element into the minimum heap, empty, to check whether if the minimum heap has any more elements, top, to check the topmost element in minimum heap, or rather the minimum element, and pop, which is to pop an item from the minimum heap. On top of that, we can also specify the comparison over here. So since we're using greater than in this case, then what this means is the elements would be in an ascending order. So we have to import queue and vector. Interesting that they will need a second parameter to priority queue. I'm guessing this is the underlying type of the priority queue. So priority queue, C++. Let's take a look at the generic type that it takes in. So it seems that it takes in three. Oh, it needs a container type. So it needs to know like what is the type that it uses. And since we are changing the compare over here, we have to specify the container as well. I'm guessing we cannot just change the type, the value of compare without specifying the container as well. So that's pretty interesting. I did not know that. So let's also include queue. So the first step will be to populate the counts of every single item in nums into the unordered map. So let's create an unordered map. And in this case, the key will be an integer and the value will be an integer as well. And this represents the num to count. So for int current num in nums, we will do num to count current num plus plus. And now we would have all the counts of every number inside this unordered map. The next thing will be to iterate through this. Let's create a simple priority queue first. So priority queue, we will specify the type it contains, followed by the type of the container, and finally the greater. To tell this priority queue that we want a greater than ordering. So looks great. Now let's specify this as the min heap. And for auto iterator inside this num to count, we will have the current number first and the current count as a second item inside this iterator here. Now the next step will be to check. So if the size of if minimum heap's size is less than k, then we would append the current number into this priority queue over here. So minimum heap insert current number. else, in this case, if the minimum heap is at its maximum size, we would check the current int least frequent, like k frequent. This is the k frequent character in the minimum heap right now, and this will be min heap dot top. So if current count is more than k frequent, num to count k frequent, then what this means is that we should pop the k frequent character from the priority queue and insert this inside. So what we'll do is num to count, minimum heap dot insert k insert current num, and after we insert it, we will pop the k frequent number from this minimum heap over here. So we just do pop, and there we go. So after this iteration here, the minimum heap will contain the top k frequent elements. So let's see if there is a way. Is there a way? How do we convert a priority queue in C++ to a vector? Okay, so since we need a vector of integers, I'm guessing the priority queue should have a helper method to convert that. So we have a priority queue with 5 elements here. It seems that, yeah, I guess we didn't get a suggestion for converting a priority queue to a vector directly. So they recommended iterating through all elements inside the priority queue and add it into here. So it seems that we can return the answer in any order, so it's not really a big issue, but let's create a vector of integers of answer, and let's do just that. So let's iterate through the for while minimum heap dot size is more than 0, we will get the current number equals to min heap dot top, and we would push it into current number, and we will pop the minimum heap, and that's pretty much it. We will just return the answer, and there we go. So let's quickly go through this with an example over here. So this is our test case. Okay, so in the first iteration, we have nums to count equals to an empty map over here. Let's create some comments over here to see how this map is populated. In the first iteration, current number will be 1, and we will add 1 to this count. The next number is 1 as well, so we increment it to 2. For the third number 1, we will increment the count in nums to count. Fourth character, BC 2, and so we increment 2's count. In the fifth position, we have 2 as well, so we increment it. And finally, when we encounter the final number, we'll increment 3 as well. So now we will have a priority queue over here, and let's represent this priority queue over here. Let's call this minimum heap over here, and k is equals to 2 in this case. So for each of these number to count will be 1, 3. So current number will be 1, and the current count will be 3. So since the minimum heap size is less than 2, we would just insert 1 into the minimum heap over here. Let's move on to the next pair. Inside the hash map, we get 2, 2. Current number is 2 and current count is 2. And since the minimum heap size is less than k, we'll add 2 into this minimum heap as well. We will end up in the final iteration, which is 3, 1. And in this case, since this condition is no longer true, we check the item that is the k frequent at the top, and we currently get so the ordering is like this instead, because this is a minimum heap and 2 has thanks to the tracing, I realized that it's necessary to not just add in the integers, it's also necessary to add in the count as well. So let's change this priority queue to take in the pair instead. So std pair of int to int, and this would be std of pairs of int to int as well. So the pair over here, first element of pair is the count. The second element is the number. So this would be greater of pair int. Yep, that's it. So we will insert not just the current number. I guess we have to do std make pair, and we will pass in, how do we make a pair in C++? Let's take a look. Okay. Okay, it's generating now. I was really close to Googling, but looks like it's loading it up. So you can call the constructor. It's really slow today. Do we really need includes utility here? Okay, this is the method that I was using, or rather the function is not really part of any class. My hypothesis is that we don't need the include import. I'm guessing it might be a mistake on ChatGPT's part, but let's make pair by just passing in the 2 elements inside. So I wasn't sure whether if I could just pass in the numbers just like that. So pretty interesting. So we make a pair and we pass in the count. So current count followed by current number like this. So thank goodness for the tracing, we were able to detect that we should have used the pair instead for the priority queue. And the reason why is because we want the priority queue to be ordered by the count. So we can't just insert the number in there. Otherwise, we would have a wrong sorting order. So this looks fine. And over here, k frequent character would be, actually rather this is a pair now. So k frequent pair. And int k frequent char is equals to k frequent pair dot first, and k frequent count is the first, and k frequent char is equals to k frequent pair second. Why I should not be using camel case here. I should be using snake case. So, it's camel case in, it's camel case in C++, so this is right. Okay, so if the current count is more than k frequent count, then we will just insert this into the minimum heap and pop this pair over here. So this looks fine. And this would change as well. Now this is an iterator. So auto iterator, and we pushing back int current number equals to iterator at the second position. And we will pop it here. So this looks fine. So let's carry on with tracing. We were at this position over here. The current number will be 3 and the count will be 1. In this case, we will hit this branch over here since the minimum heap is of size 2. Now k frequent pair would be, so let me just correct this. Now this is a priority queue where this contains 2 2 and 3 1. So over here, like the k frequent pair over here would be 2 2, and k frequent count will be 2, and k frequent character will be 2. In this case, the current count is not more than k frequent count, so we will not do anything over here. So let's move on to the final step over here. So minimum heap size is 2. So we will check the top of the minimum heap. In this case, this will be 2 2, which is the second most frequent element in the priority queue. We will get the current number, getting 2, and we will push back the answer with 2 over here, and we will pop the minimum heap. Now the minimum heap size will be 1, and this will contain the final pair inside minimum heap. This will be 3 and 1. Current number will be 1, and we will push back 1 to the answer here, and we will pop minimum heap of its final pair. And that's the answer. So from a quick trace, this seems correct unless I make some mistakes in the syntax. But let's run this through. Okay, no member name insert. What's the method for inserting into a priority queue again? I'm guessing I made a mistake somewhere. So let's check. Okay. The method for adding an item is not insert for a priority queue, is push. So this is very helpful. Okay, let's try running this again. Okay, no member name insert. Okay, I forgot to change that as well. Let's run it again. No member function called push. But the minimum heap is a priority queue, right? So what? Oh yes, of course, because I was pushing an integer instead of a pair. So I have to make a pair here and pass in the current count together with the current number in this pair. So that's why it's failing. I was passing in the wrong item into the minimum heap. K frequent pair. That's a typo in my implementation. Yeah, it's quite unfortunate, but tracing doesn't fully de-risk the situation of making typos in the code. So okay, looks like it works fine. So the time complexity in this case is on plus k log k, where it's on to populate the unordered map and k log k to populate the priority queue, as well as iterating the priority queue. So this is going to be OK. Sorry, it's OK log k, because popping an item from the priority queue is going to take log k time. And if we do it k times, then it's going to be OK log k. And similarly, in this case, this iteration here would be on in time. This will be on as well in the worst case, since we're iterating through the whole map. And over here we are, and for each of these operations, yeah, like in typical cases, this will be on plus OK log k as well, because we will only push and pop up to k times. We will not do it more than actually no, does it? It's possible that we would Yes, it's possible that in the worst case scenario, if the numbers were ordered in an ascending order and we go through the unordered map in a way such that we insert the numbers with the smallest counts first, then we might run into a situation where we would keep popping and pushing into this situation here. So this might be n multiplied by OK log k. Sorry, n times OK. N times O log k. So in summary, the time complexity is On plus O n times k log k plus OK log k. So it's pretty nuanced. And since this is On times k log k, this is the smaller base, so we can remove that. And this is a smaller base as well, so the time complexity will be On times k log k. The question is, how big can k be? I'm guessing k is a smaller number, so it's not too bad. But we got a pretty fast submission, so my guess is that in the test cases, k is a pretty small number, and that's why we were able to do it pretty fast. So after taking a closer look, I realized that I made a mistake in a little typo here. So previously it was n times k log k. This is not true. It's because we do this log k insert and push and pop here and up to n times. So this is just a little typo where I had this k in front. So the time complexity is n times log k in this case. So that's pretty much it for this video. I hope this was useful, and if you like it, we hope to see you in the next one.